on to agenda action. So first is working group status. I'm sure no one's going to have any trouble with that. We'll talk about working service benchmarks with Mr. Haber. Fixed function, network function book area, the benchmarking considerations, and SDN controller. And these are all the folks that will make those presentations. Be sure you get the blue sheet there, Mr. Rumsey. Welcome. So, and I guess both Barry and Rumke are here. So did I get the presenter name right there, guys? Were you going to do it? Okay. All right, very good. So any dashes to the agenda? Seeing none, we will continue. All right, so here's our quick working group status. We carried over a couple of drafts from our previous charter. These were the SIP networking device benchmarking drafts. They are now IESG approved. Also, BGP data plane convergence benchmarking draft is IETF approved. Just seen the RFC editor begin to ask questions about our drafts. We're about to resolve a few last-minute editorial things with them. And I guess BGP data plane convergence will follow. So the active drafts in the group, I guess about 8 months ago, we picked up the traffic management draft as a working call item for the charter. We had the third working group last call, and the sort of the document shepherd for that. I'm willing to call consensus on that, unless anyone wants to go to the microphone right now and bring up a major issue that I think about this draft that violates the law of physics or presents another problem. So seeing no one rushing to the microphone, I think we will declare working group consensus on traffic management after 3 working group last calls. So before my hard drive crashed, I prepared the Shepherd's questionnaire, the document Shepherd's form, and uploaded it to the Data Tracker website. So soon, Joel, we will be pressing the application request on the traffic management draft. But I think Barry, there was a couple of things you wanted, Barry and Rumke, really. I think there was a couple of things you guys wanted to sort out from that last round of Shepherd review comments. That's correct. I see you nodding. Want to go to the Barry? Oh, okay. You'll handle it then. Got it. Perfect. Thank you. I realize that often status I try to rush the whole meeting, so I'll stop doing that. So we'll talk about that bit in traffic management. So we had a call for working group adoption on the data center terminology and methodology, and also on the IPv6 neighbor discovery. And there was a very strong response on data center benchmarking. Lots of people came out of the woodwork who never heard of before and supported the drafts. And a few of them joined the mailing list. And so now here's the good news. All those people get to review the draft even deeper and provide comments. And so once I get up and running here again, I will be sending that email out to the list. and in truth, it was a strong response. If we get 50% of those people looking at the drafts and providing meaningful feedback, we've got an excellent review team. So I thank Jacob and Lucian for beating the bushes to get all those new people involved. That's really great. Thank you. So let's talk about IPv6 neighbor discovery. Support for this was a little light, but I would like to ask one more time here in the room for folks who had a chance to look at these. Actually, you know what, Johnny, rather than ahead, we'll let you present your slides and then ask. Let's do it that way. So let's get the whole meeting over in one slide. I've caught myself doing it the second time. It's good. So we've had some good development on the network function and virtual network function and related infrastructure drafts. And, summary of estimates to the loop from you, Bhuvan. Thank you. That went out yesterday, and folks can take a look at that. New work proposals keeps coming, and so I think that I'll say more about this later. But it's a real time of renewed interest, and I would say some kind of renaissance in our work here. I'm really glad to still be involved in this, and that we've got a vibrant work community here in benchmarking, because it's about to get even more interesting than it ever was. So next slide. Oh, Sarah, go ahead.
We actually just one thing. Between last week this week, the ISM2 draft and working with last week. So thank you for the feedback from the staff.
And sorry for missing that up here. I guess I ran out of bullets. Okay. So for folks preparing new drafts, it's important from the point of view of the security folks that we have a scope, and the scope has to say something consistent with our charter. This is laboratory benchmarking in the isolated test environment of a lab. Because if you were to do these things out on the wide open internet, you would clearly mangle some traffic, make things difficult for others. And so we have this standard paragraph that very often appears in the security considerations section. So security reviewers who may not be familiar with our charter, and if they don't read this in the scope, they need to read some things like this here. Now it's perfectly reasonable to customize this, but that's the main point here, that we have testing that takes place in an isolated test environment. Okay. So if you're just coming in, please sign the sheets and sign them. Oh, okay. Anybody need it besides this gentleman? Oh, Ron Peter. Right. We'll bring it to you, Ron. All right. It's a good turnout today. Okay, so current milestones. I've actually marked some of these done, and they're all the ones that we talked about before on BGP and SIP. We're a little bit behind on traffic management, but we're making progress there, and on these others as well. So I think we're doing pretty well compared to our original plan, which is typically aggressive. So what else have we got there? So on the work proposal summary matrix, because we picked up lots and lots of items on the charter, I've basically moved quite a few things off. I've basically just said, look, there's work that has been proposed which doesn't directly match up with the charter items, but in my view of them, they're all in the scope of BMWG. So we've got proposals, we've got drafts. In at least one case, we've got significant support at the meetings and significant support on the list. So this is how we track drafts up through charter adoption. And I think that for each one of these topics, we could eventually get to the point where we've got charter work that we take up. And some of this, I would guess that SD infrastructure and vSwitch benchmarking, they would both be covered under the infrastructure work item that we've been talking about, because we couldn't make it that broad. But the first deliverable is this consideration draft that we'll say more about. So anyway, that's the current status, and there's space for proposals as well. Let's see. So no new DFCs. We haven't updated our charter. There is a supplementary BMWG page. So if you're new to the group, there's a sort of a quick start place there. my personal page on Comcast. I wrote some notes about doing it, and I think they're still valid today. Some of the stuff that there's a little out of date. Don't let that bother you. Okay. So I think that very much does it for the chair slides. Yeah, this is okay. This is the names of the drafts that are still active and working their way up to adoption, and some of the things that here that are recently active, some quite some time ago. But these are all, these are a lot. There was a lot of good work, especially in the power usage and data center bridge benchmarking, content-aware benchmarking, and the LDP work as well. So some folks may want to try to renew this if they still think it's valuable. And the text is available. Okay, I think that does it. All right. Thank you. Next up is Romke or Barry. Barry's going to do it? Okay.
Okay, we good? Okay, thank you. Yeah, for those of you who've never seen this before, it's the traffic benchmarking framework. We started this, I want to say, about 18 months ago, but there's been a lot of good involvement with everybody up front for all the good input. But we can go to the next slide, please. So I would like to share the slide first, just to give context of, the motivation behind moving forward the traffic management benchmarking. We all know well our RFC 2044 has set out to achieve and has done so extremely well still today for all the types of tests that it does, and we've identified a need in the industry to go ahead and test some more of the advanced traffic management functions, so that requires the definition of some procedures to use stateless and stateful traffic. I think that's one of the things that resonated with some of the early interest that we got in it. We wanted to try to come up with ways to standardize the way you would actually define TCP layer traffic flows to be able to test some of these more complex functions that in some cases you can't even test the traffic management function without traffic. I tend to move around a little bit. Okay. All right. Okay. Next slide, please. Okay. So, Echo, you said that it would be good to present a summary of the WDLC changes. Something's happened between now got presented. We had a lot of good interaction with the AQM working group. They got very interested in we were trying to begin with the definition of how do you do stateful TCP tests and benchmarks, and so we actually had a meeting with the developer of one of the tools that they use, which is called NetPerf Wrapper, which is a scripting interface to actually a NetPerf source tool, which gives you a lot of the kinds of TCP layer flows. And so we met with a live web conference with Toki. I'm not pronounce the names well, Jorgensen. But so we came out of that meeting was that the NetPerf wrapper could do some of the things we thought were necessary, but not enough of the interactive request response type behavior that applications that use TCP would use normal communication. So we did some research on a tool called UPerf, which is, I guess, if you would think about those of you who are familiar with the open source tool IPerf, UPerf took that one step further. So they identified the need to emulate applications without actually running the whole application, and the author's very active. It's a very elegant type of architecture. You have XML descriptor, that I can go ahead and show an example of that a little bit. An XML descriptor that you can just lay down. Here's the client and server. Here's the amount of bytes that transfers between the pairs, how many times that happens, a very nice amount of control. And the thing that's, obviously is desirable about that is the fact that we can come up with templates and just say, these are defined patterns that you run with this type of tool. And if you want to do the test under all the different test scenarios, you're doing the same exact sequence each time. So we think we did some additional benchmarking with the performance. It's encouraging on just kind of normal commodity hardware, laptops and things. So we added it to the list of recommended tool sets in terms of what you should use in terms of the traffic benchmarking for TCP traffic. Okay. Yeah, so now onward, there was a lot to talk about, so I tried to highlight the key things. We had two working last calls, yes, really three, but I think there were remain two. We had 3 detailed reviews from working group members. I really want to say thank you for those. Those really took the document from being kind of drafty to more of a formalized, readable document. And one of the, some of these here below Al did a tremendous amount of review, and I think I tried to highlight the most important ones. Repeatability and test result was lacking as far as the procedural elements. And it was too general. So at point was to advance. Thank you for that. And we were able to look at the way you did your sections and thought that was very good. So we added that to each of our sections of the format, and we're trying to secure we got the results, requiring multiple trials, things like that. Metric refinement, again another input from Al. So we got into specifying more detail on the metrics themselves and referencing other RFCs that was relevant to the metrics. The amount of variation allowed between test results and measured results. There was a whole bunch of other things. These are the ones that come up to the top or to my head to summarize. And there were some questions that we answered, and I know some normative and informative. We have a draft 4 ready to be published. So that's the last slide.
Yes, it is.
Okay.
The last set of comments, as I mentioned, were as a result of the Shepherd's review and go through that form. And it was mostly the formatting thing and outline things. And I think I found a couple of references reading through that weren't actually referenced. The MEF, those 3 or MEF documents.
We fixed all that.
So if we get that and all prepared, and now the submission for internet address is opening.
Okay.
So if we can get that draft submitted, then I will basically push the button on publication.
Okay.
And well, before I say that, any last questions? Really, questions or comments on that work? I think that this is a good opportunity to get some sort of even a basic level question in if you're interested in this. Seeing none. All right. I think I'm going to press the button.
Okay.
All right. Let's get the button in front of me. Barry and Ramki, thanks very much for your efforts so far. By the way, it doesn't end here. The next guy gets it is sitting right behind Ramki there, Joel. And Joel will provide his review.
Okay.
And we're may see another revision, and then off the IETF where it's get really interesting.
Okay.
Jacob, yes.
Okay.
Just more comment than the question. But, Jacob Rapp.
Yeah.
So there's other tools out there that we can sync up on from the TCP and stakeholders. We've done a lot with being around TCP and stateless.
Okay. Are they open source?
Yeah. So
okay. Oh, great! I'd like to include that in the section of So I always find that useful in RFC when I can find some.
Yeah, definitely. I've used all the tools that you were mentioning as well.
Have you used the
I don't know if
Okay.
There's a TCP generator that Stanford uses for their data center TCP.
Okay, I'll send you a note. I'll send you a note to get those names.
I think the best thing to do for all of us, Jake, would be post it to the list.
Yeah, that's.
Just a set of links and maybe a few words about your experience with these things, what you and that would be very good background. And I've been wondering what would be a useful update for the little supplementary page I keep on my Comcast site. And I think it's always going to pale in comparison to the CADA site. They have all these measurement tools. Although maybe those things are listed there as well. But I think for things that we find specifically useful to benchmarking, I will make a note to myself.
Okay,
to
good.
start to collect these links to these things on the supplementary page. Be a good reason to update.
Okay, thanks, Jacob.
Can I point out, this time around in the minutes, I'm actually keeping little action items. So Jacob, since you agreed, you're on there. And I'll send that out to the list after the meeting. Thank you.
Marcos Jordisco. So, following on the example of
the author is very active. So there's some things that we think that need to be added, and he seems willing to add them. So it's always nice when it's not a tool that's just sitting in the
Exactly. I've heard that said, unfortunately, about IPER, and but that was actively being developed, and some of the other stuff.
Yep.
Scott Bradner. Just looking quickly at the document, say test runs, for example, under traffic, under section 6, test runs, number of test runs to see if they're sure accurate and repeatable results, and the recommended value is 3. Is there a particular reason for 3?
Oh, well, I think there's room for, subjectivity there. I mean, that's just a number over my years that I use.
How long does a particular test run take?
Okay, is that not specified? I'm thinking.
I'm just glancing at it.
Oh, you're glancing. No, I think we said a minimum of 60 seconds, but I'd have to go ahead and double check.
When I was doing tests, I would do a repeat, anywhere a test took under a couple of minutes.
Okay.
I do a repeat cycle of 10.
Okay.
Because it doesn't take much time to do. And
Okay.
It gives you much better results.
Okay. I can look at that.
You'll find that that with the 2 or 3 repeats, you're going to get some outliers.
Okay.
You won't know what to do with.
That's a good point.
Yeah.
That was probably the efficiency side of me. Sometimes I think about. Okay.
Okay, Maurice again. Following up on Scott's comment. In my experience when testing 10 or 20, like the bigger the sample size,
Yes,
the smaller
okay.
the standard error from the average. So maybe 10 is a good number. I don't.
Okay.
Or I don't know. Is it? This is a question for BMWG. I haven't really seen that happening in many of the drafts. Is expressing the error something that would be beneficial?
Scott Bradner again. The answer to that question is yes. Expressing the error is definitely a useful thing. It's not been generally specified in the document you should do so, but it's definitely a useful thing. You might think about, just philosophically, that the number of repeats should be based on how long time you have for the testing.
Yes.
So if you can do 100 repeats, and certainly some of the tests that I did 100 repeats because they were 10-second tests.
Okay.
So if you've got a day to do it and each test takes a minute, then do a lot.
And especially if it's automated, right?
Well, I'm
Yeah.
making the assumption it's automated
Yeah,
or you're
and
done.
the results, yeah. Right. Okay, thanks again. Okay, you got that? Okay.
Again, thanks, and thanks for the feedback there. It always amazes me that Scott gets through the draft to something worth commenting on, and he probably hasn't opened it until the first slide shows up. So, thank you, Scott. Scott's our chairman emeritus. He started all this work out a long time ago. I won't say how long ago, but a long time ago. And it's always a better meeting with you. Thanks, Scott. It's interesting draft to work on. Thanks for okay. So now we're done thanking each other. We'll get the 04 up with that change of excellent. That's an action. Working on this agenda. So next is Sarah. We'll just switch chairs if you want, Sarah. I had it up, though. I thought that, Here it is. There it is. Okay. You're going to stand over there on the slides.
I have to stand today? Really?
Yeah, you're going to stand in the box. You're going to think inside the box.
Hi. This is a quick update on the ISSU methodology draft. Between last meeting and this meeting, we moved into working group last call. We had also at the last meeting adopted this as a working group item, but the draft had been under review and work, I think, for almost 2 years. So it was a pretty quick adoption when we rechartered, and then we moved into working group last call. Lucian and Jacob make us look bad because we certainly did not have 15,000 people come out of the wood and support the draft, darn. But there has been pretty good feedback. In particular, I think the most extensive that we received this time through was Al. So thank you for that. We received 3 reviews, one privately that I've asked to go to the list and it hasn't come in, and then 2 on the list. We started and we updated the draft that's posted, so you'll see it renamed. I think somebody had made the point that, hey, it's still not in the correct name for a working group item, and that was just timing.
I actually explained that when calling the working group.
You did.
Call.
Yes.
So,
thank you.
Okay.
Yeah, no problem.
Next time it'll be fixed. That's easy.
Yep, and it's fixed, so that's up. We were also in the process of moving away from the Word template that somebody, Al, did not like us using, and moving to Cramdown. So if anybody else is actually using Cramdown, I would really like to talk to you afterwards. But we had an issue generating in Cramdown, so coupled with the cutoff for updating the draft, we think most of the feedback is in from Al and from Dave. We've renamed the draft, so that's posted, and that was posted just before the cutoff for this meeting. So what you see there is the latest and greatest, which should be good to go. And we're looking for support, and more importantly, more reviews. So I think the 2 different companies that are working on this, or I guess I'm not included, so 3 companies that are working on this now, we we've been doing this for a long time, and sometimes having that new set of eyes really, really helps. So please, if you're interested at all in how to upgrade your device without a service window, with no outage, hopefully on the controller data plane, please take a look and let me know.
So here's some good feedback, Sarah. In the open platform for network function virtualization that I'm involved in, there was a project proposal called Escalator. And Escalator is basically about in-service software upgrade
Oh, wow.
in the virtualized world. So I have pointed these folks, who are still at the proposal stage, to the draft, and hopefully they will read it and provide some feedback. And I think their wiki is is openly accessible. If it's not, that's not going to help. But if you have a Linux Foundation login, you can almost certainly get to it.
All right.
And so it's and really anybody can get a Linux Foundation login. I think that's the way that works. So anyway, let's keep an eye on that as a potential source of feedback for this as well. There's a new group of people starting to think about this in the virtualized space.
Okay. Any questions? Feedback? Thank you.
Thank you. So Jacob, you're up next. I hope the frame is fine enough to catch all of you there.
So this is on the two drafts that we have, one on methodology and other on definitions. So we can go ahead and move forward.
Okay.
So this is kind of an overview of where we're at with the draft. The ones in green we've had good feedback on and updated. The ones in black are still kind of the original text that we put together. So if there's any other feedback or any other comments, or if you want to take a look at those sections specifically, it would be greatly appreciated. But I mean, from the last meeting, we haven't really had any updates past that because I think that there wasn't really much comments outside of just the support for adoption on the list. But I mean, it's the updates. I mean, for those who haven't seen the drafts itself, we're looking at updating, or actually not updating, but adding on to the RFC 2544, 3918, and 2889 with specifically for the data center, and looking at devices in the data center around what's the definition of jitter, latency, physical calibration, line rate, looking at buffering extensively. There's a lot of information on buffering in there. Burst testing down here might be interesting for the previous section is the incast stateless and stateful traffic. It's a little less complicated than the quality of service and traffic metrics, but it's more of benchmarking the buffer in incast scenarios. And I did send the link to that incast generator out to the list, so you can mark me off as I finished my my action item.
Next slide.
Yeah, next slide. So we started the draft back in IETF 86, and we've updated it since then. Good support on this, so we actually went out we've been using these drafts with a set of customers, so we went out to these people and said, hey, if you've been using it, finding it useful, send a note, because they've all been kind of actually a lot of them have been actively using it in different scenarios, some of them. So I think I put down most of them I could find. I may have missed a few.
There's 16 names there. That's a lot.
So it's something we've been working on for a few years, and even before that, we've had customers and people that have been using it, these types of methodologies actively. So it was something that.
That's where the best methodologies come from.
Yep.
Lots of use, lots of feedback. So.
Yeah, exactly. So I think we're. I mean, from our standpoint, I think we're pretty good. But if there's anything else, if you want to review it more, then.
Could you back up? What I was about to say. Could you back up one slide?
Yeah.
And look, you can. So the green areas here, Jacob. These are the ones where you feel you've gotten.
They're the ones that we've gotten comments on, really.
Okay.
So it's not the. I mean, we haven't gotten any comments on the black.
Okay.
So it doesn't mean it hasn't been reviewed, probably, but just no comments have been made on it.
Come inside the box. Yeah.
There we go.
All right. So basically, it's an open call for comments on everything.
Sure.
But there's some background material probably on the mailing list or somewhere that
Yep.
refers to the green item.
Yeah, on the mailing list or in the notes from the previous meetings.
Yeah. Very good. All right.
Good question?
So Marius, one small comment. Basically about repeatability. You don't exactly specify a number of repetitions. You say you should, or I'm not. I don't remember exactly how
Sure.
it's worded in the text, but there's no exact number specified. I think it's beneficial to have it's my personal opinion. It's beneficial to have a exact number of repetitions, and coming back to maybe expressing some kind of error associated with that number.
Okay, yeah, that's a good feedback. Because I think we have a lot of how many iterations to run, but it's from like, okay, for the buffering, for example, it's okay, run from this port to this port, this port to this port, this port to this port, until port N, but it doesn't say, okay, do repeat that X number of times. So yeah, it's good feedback.
Scott Bradner, I think we talked about this the last meeting. The experience I've had is buffering testing generally is not terribly reliable.
Yep.
Not very repeatable. So,
Okay.
And that using that as a code, I would repeat what he said and what we talked about in the last internet draft. Encourage repetition is
Okay.
and testing reliability is an important thing. So you can get some very misleading results if you just run it once.
Okay, sure. Yeah, good feedback. And I think we, in, I don't know, what was 87 or 88, we presented some of the results on the buffering testing that we repeated multiple times, but to add that repetition in there is good in the RFC itself, or draft.
So Alan Morton making a comment as a participant. We have begun to look at delay variation again in the context of OPNFV, this open platform for network function virtualization. And we have a very refined definition of jitter there. It's the PDV definition from, I think it's RFC 5481.
Yeah.
If I'm right. Believe me, the numbers are getting harder to remember. I'm not sure where we ended up with this one, but I'd like to see some coincidence between what we think is worthwhile in the virtualized world and in the data center world where maybe the emphasis is both on physical and to some extent a virtual.
Yeah, that's a good point. And it would be good to look at. I was reading through your draft earlier, and there's a lot of synergies there. The packet delay variation, I think, was the metric we used for it. It was just specifically calling out that because there were so many different definitions of jitter, and it was you just got to pick one that made the most sense and standardize how you even report it as well.
That's right. Well, and the truth is, you don't have to pick one. but you should pick the one that tells you what you want to know.
Yeah.
And
Exactly.
if you want to know, the sort of the histogram or the distribution of delay variation. There's get that, and it's a fairly simple way.
Yeah.
But otherwise, I think we ran across the same questions in back-to-back testing or buffer testing, and I made I recounted.
Yeah.
Oh no. So in any case, I think this is headed in the right direction, and now we need to get you've got a lot of tests here. What we need to get is some review of this full spectrum of things,
Mm-hmm.
because that's because in the end, when we're drawing consensus on this draft, it's consensus on the whole thing.
Yep.
So it's going to ask us to sort of be spread thin. Maybe if people are actually going to run some of these tests themselves, maybe to divide up the work and bring back implementation results of some of these tests. That would be.
Yeah, I mean, actually, most of these tests are scripted in some of the standard testing tools out there already. So we have.
Jacob, you've been around here long enough that I think you realize that when people's blood really gets flowing here is when they see actual test results up on the slide. So let's do it.
Following on Al's comment on NFV, I think Al made a comment, and he wants to essentially say that there is the NFV infrastructure, the hardware basically, physical structure. I think anything in layer 2, 3, 4 with virtual devices. And also the fact that NFV, basically is so then it may be worth looking at this draft from a lens of NFV and see whether there's specific that we. I mean, of course, this is generic data. Use more of a distributed data center where we're kind of virtualizing the central log.
I mean, I think this draft was stopped at that point because we wanted to refine the device itself, the actual physical hardware itself. So we clear in the definition of the drafts that's what we're looking at. And then when you look at NFV, you're going into like virtual machines and I mean, there's also the vSwitch test I was looking at and other things that can be added upon this. But I mean, we just want to stay focused on the physical device.
Yeah. What I meant was to clarify, not even vSwitch, but stay physical, but look at NFV requirements. Even the NFV infrastructure, like layer 2, 3, 4 switches. We have vSwitch, but still
But then it just comes back to is the traffic TCP, UDP,
everything will be back on
flows, right? I mean, it's just flows, packet in, packet out at that point.
Still, there is a carrier gate requirements aspect which needs to be considered and NFV environment versus the generic data center benchmark. So that's the aspect I was trying to see whether what I think it's a very valid point.
Okay.
Scott Radner again. You might consider, you just mentioned that what you're trying to do is improve the devices. Good thing to do.
Mm-hmm.
But one of the little crises we have on the internet these days is what's euphemistically described as buffer bloat.
Yep.
And so you might, I don't know whether you have it now, but if you don't, you might have some text in there that points out that two buffers that are too big get in the way and make things worse. And that TCP requires packet loss in order to do flow control. So I worry about anything, any kind of testing, like the FCC's recent the Title II announcement said, well, we're going to measure packet loss. That's going to encourage ISPs to not lose any packets, which you don't know how to. So any place a bigger number might be seen as good, and yet it's not good. You might want to put some kind of envelope around it.
Yeah, exactly, and that's actually the precise reason why we added this last test in, is that, yeah, you can measure how big the buffers get, and it's actually, as a vendor, it becomes a really big issue because people, I don't want to drop a packet, I don't want to drop a packet, packets, so we have to engineer ASICs with larger buffers, and then the larger, more buffers, the more expensive the chip's going to get, and the more price that the customer has to pay for it. So it's even bad all the way around from there. But then the bigger the buffer gets, it affects latency. So it's actually a bad thing.
It doesn't just affect latency.
Mm-hmm.
It affects actual performance.
Yeah, absolutely.
So it gets into a position where it's not just that it's a long time, it's very slow.
Yeah.
So instead of being a megabit a second, it's 100K a second and long.
Mm-hmm.
So it's a combination. There's some kind of wording in there that indicates that the bigger the buffer is not the better the buffer.
Yep. Okay.
Right size rather than giant size.
Absolutely.
Well put. Anything else? Okay. Thank you, Jacob.
Thanks.
And thank you, Lucian, if you're listening in Jabberland or something like that. And
in Japan right now.
Oh, in Japan. Okay. That's actually pretty close to Jabberland. You just have to get rid of a few letters. So, all right. Let's see who's next.
I'll be in this little corner here and still be in. No. Okay, I'm Bill Cervini. I'm one of the authors of this draft that talks about IPv6 neighbor discovery, and I want to use the term problems. Ron Bonica, who is in the third row in this room, is the other author. Next slide, please. So we've had a bit of history. So at IETF 85, which I think was in Atlanta, Ron Bonica suggested that, well, there's this RFC that talks about neighbor discovery problems. It would be useful to be able to benchmark this in some manner. Based on that, I wrote a draft to version 0.0, which I presented in Orlando, Florida. Oh, I'm supposed to go. Oh, I was on the edge. So if I stand on the line, is that illegal, or I don't know? Am I out of bounds? No.
In tennis, it's called a football.
So draft 2, or draft 0.2 was discussed at IETF 88 in Vancouver. Let me move on down. Draft 0.5 was discussed in Toronto. At that time, there was some discussion about compliance versus benchmarking, and Ron and I talked a bit in November in Hawaii over some really good Hawaiian food, and came up with some ideas about how we would adjust it. I made those adjustments in January of this year. And next slide, please. So, what is neighbor discovery problem background? Oh, this too far? No, okay. The problem is described and documented in RFC 6583, the operational neighbor discovery problem, of which Joel is one of the authors. The concept is that it's hard to, so in IPv4, it's relatively common to scan a network. If you do that with IPv4, you run out of addresses before you create a lot of problems with your intermediate device, whether that be a router, potentially a firewall, potentially any number of devices. You can't really scan a full IPv6 subnet. Typically, a subnet in IPv6 is 64 bits. It takes a really, really long time. So, depending on who you talk to, it could take 27 years. So scanning isn't something that will discover potentially every node in the network, although there are things that are discussed in 6583 which make that easier. However, if someone tries scanning the entire subnet, they can create a lot of neighbor cache state, which can certainly cause issues for nodes trying to traverse traffic across the intermediate devices. The intermediate, bad thing can happen. Next slide, please. So, one of using RFC 65A3, this document is a benchmarking instantiation of measurements which try to define how a intermediate device handles the neighbor discovery problem issue. So as I say, it characterizes how a node behaves under stress due to heavy neighbor discovery activity. Next slide, please. The test setup is pretty basic. You have a scanner endpoint and a target network endpoint. The scanner endpoint conceivably is outside of the target network, and it essentially tries to discover a very large number of addresses on the target network. You have neighbor advertising coming from the intermediate node and neighbor solicitations coming back. You have a lot of state being built up in the intermediate device. Next slide. So we had, I want to say, either 5 or 6 tests as of November. After Ryan and I talked, we cut this down to 3 tests. The tests that we took out were mostly compliance. First test is where we just establish where the stale entry time, what that value is, because that can vary depending on the device. It can actually vary over time. So you need to capture this value every time you run this series of tests. From that point, we discover the neighbor cache exhaustion, and we isolate the point where the cache is exhausted, and we evaluate the behavior when the cache is exhausted. We first determine the scenario where the cache is exhausted and confirm that the box doesn't crash. If the box crashes or does weird things, we don't need to go to step 3. There's a problem with the device. This is an intermediate step. There really aren't any metrics per se in this step. It's an intermediate test. The third test, which is probably the most interesting, is determining the number of flows which are dropped in a minute. So this is the point at which the neighbor cache has been exhausted. What's also particularly interesting is to confirm what type of flows are being dropped and how rapidly the flows are being dropped. So are these flows that have gone stale? Are these flows that have never been established in the neighbor cache? We want to confirm, this is sort of a complaint, but it's also useful to know how well the device handles under load, and we essentially establish a metric for that value. Next slide, please. Okay. Okay. Maybe we need 2 lines. One, I stand on the edge of the line, and no. Okay. So at this point, we thought the draft is ready for implementation, ready for adoption call. Marius had a very good point. At this point, when I first created the draft, it was called benchmarking IPv6. That defined the scope very concisely. At some point along the way, I dropped the word problems, which broadens the draft to beyond discussed in 65A3. It talks about a whole host of other types of neighbor discovery behaviors that can be benchmarked. Intention of this draft was to be and what happens with RFC 65A3. So either accordingly. And that's all I have. Scott.
Scott Bradner again. A couple of things. I'm one who would object to the word problems because benchmarking is a funky stuff. Now, how screwed are you kind of thing is not all that a useful thing. It's more if you're benchmarking, if you're testing for problems, then you're testing for problems, you're not benchmarking. This is my side, my feeble mind on this sort of thing. But that's just my opinion. But what I got up to ask was, can you explain a little bit more about this flow stuff? If you're testing whether a neighbor discovery is working, when it overflows, does the traffic stop through that node, or what's going on? I just don't parse it.
By the way.
Ron Bonica. Is to add an entry. The net kernel crashes, but the router just crashes. That's a bad behavior. That's probably the worst. The next is that you're trying, the device itself is trying to can't, because other route stands to entry center. You want that one to take the highest priority. Another possibility is you have addresses that you know are active, but they refresh because they've been selected by the guy doing it. So the references, it talks about behavior, who should take, and the question is, does it happen? Or you get priority over a request that's originated on box.
So I think what you're saying here is that the test is to be running a stream from point A to point B that's going through an intermediate point that you're testing the behavior of neighbor discovery on.
Yeah.
And if that intermediate point craps out or does something like not refresh properly, then that flow will die. Yes. That's the point. So you're not really testing flows. So maybe you don't want to call it testing flows, because I didn't get it all from the name. And what is the neighbor discovery timeout?
It can vary. I don't remember the exact numbers, but it varies. I think it's supposed to be some random between, I want to say, right around 45 seconds, but it varies every, I want to say, 2 to 4 hours. So that's why it's important to run it every time.
45 seconds. That's going to be some runs to see when flows stop. That out. You might want to reword it, because you're not really testing for failures of flows. You're testing for failures of devices which will cause failures in flows.
Right. We're not benchmarking flows at all. Benchmarking.
That would do it too. Yeah. Benchmarking IPv6 neighbor cache behavior. And that's okay with Scott? Woohoo!
Does Scott get a bonus for having the new title?
Yes. He gets the beer of his choice anytime he sees me where I can buy one.
Okay, so that's all that's from the floor. Back to Al. I wanted to sit down in the box too, but
Extra points for
don't jam it in too hard. It's got to come right back out again. All right. So I mentioned that we have this little option, sparse. I'd like to open the opportunity for folks to come to the microphone now and support this work if they think this is worthwhile adopting in its current form with the name change as proposed.
Hello, Marius. As I said on the mailing list, I strongly support this draft.
Okay, good, thanks. And we did get one or two others supporting it on the list. Anyone else from the floor would support this work?
I think with the caveats that we've just discussed, it's good stuff.
Okay. Well, I think with this, incidentally, Rumkey, I was wondering if you were coming to the microphone there. Or are you just fixing something under the... All right. Stopped. All right. So I think with the fundamental area, I believe we have enough support support to take this forward. And it is working a problem that we've already identified. There's an RFC that describes that problem. We won't use the word problem in the title, but we will work this area. So congratulations on. We look forward to your next begin more intensive searching for reviewers and we get these last few details sorted out. So, okay. Very good. Blue sheets. I know the blue sheet is right here. Has anyone come in recently who has not signed the blue sheet? Yes, a few people. Okay. Oh yes, so it's Marius.
Rockstar. There you go. On the edge.
We're accepting beer all week, so when you're out of the box 3 times, we'll meet you at the bar at noon.
But what if you're standing on the line? Well, how
On the
about
line, no, in the box.
No, that's football.
I like to be on the edge. That's why.
Yeah, on the line, it's a beer.
Okay. I'll try my best to stay within the pink-ish box. Okay. Okay. So, yeah, my name is Marius Georgescu. I'm from Nara Institute of Science and Technology, and I'm going to talk about an updated draft, which is about transition technologies benchmarking or benchmarking methodology for IPv6 transition technologies. So I will start with the draft overview. So basically, RFC 2544, which I'm pretty sure everyone knows, and RFC 5180 address both IPv4 and IPv6 performance benchmarking very well. However, transition technologies are outside of their scope, and this draft is proposing complementary guidelines for evaluating these transition technologies, and well, part of the motivation is the transition technologies are quite diverse. So within the draft, I'm trying to find a way to generically classify the transition technologies, first of all, in order to get some test setups going, because how do you set the test up for testing them without knowing which category they're from. And another important addition, I would say, is the calculation formula for the rate at which the frames are generated, which should take into consideration the frame size overhead, which can be created by the encapsulation or translation process. The draft also includes a tentative metric for benchmarking scalability, which sees scalability as performance degradation, basically. So we're creating a bigger number of flows and comparing with a single flow, and we can get the performance degradation as relative change between the performance of the first flow. And also in the new version of the draft, I added some benchmarking tests for stateful IPv6 transition technologies, which take into consideration, or most of them have a state table. So the efficiency with which the state table is managed, I think it's a quantifiable and important part, and the benchmarking tests are
accordance with RFC 3511, which is for benchmarking firewalls. Yeah, so in the next slide, please. In the update overview, the biggest changes are these added benchmarking tests for stateful transition technologies, additional tests to distinguish between the 6 to 4 versus the 4 to 6. Comment I got from Scott last meeting, specifically for translation-based transition technologies, and also recommended UDP for the testing forwarding performance because, well, yeah, it offers a better baseline for comparison, basically. And TCP traffic for section 7 benchmarks, which, well, TCP is in the title of the metrics, so it needs TCP traffic or some sort of transport connection-oriented transport protocol. So also another comment was about testing the scalability of the customer edge devices as well. And that was from Andrew McGregor, and I didn't actually build a well figure for that because it might be too complicated, but I added in text M2N test setup, in which M is the number of network flows that go into the customer edge device, and N the number of customer edge devices that are connected to the same PE device. So yeah, that would be pretty complicated as a figure. Then added some MTU and routing recommendations, and clearly specified that multicast performance is outside the scope of the document. So I think I'm gonna. Well, okay. Let's go to the detail in the next slide, please. So about the update about the stateful versus stateless. So basically, I didn't really discuss or I don't think there's a need to add benchmarking tests for stateless transition technologies. Only to add for stateful transition technologies to quantify the efficiency of the state table. That's my exception, at least. And I gave a definition, a generic definition of stateful transition technologies, which essentially are technologies which are using a state table to create dynamic correlations between IP addresses or IP tuples, like IP address, transfer protocol, and transport protocol number, which are stored in a state table. So I think from the RFC 3511, two of those are enough to see the efficiency with which the state table is managed. So concurrent TCP connection capacity and maximum TCP connection establishment rate. Okay, so next slide, please. As for the 6 to 4 versus the 4 to 6 translation, I clearly stated that fine-grained tests can be set up. So for translation-based transition technologies, they can be tested with the first test setup, which is the single device under test. So additional tests can be done to see what is the performance of the 6 to 4 versus the 4 to 6 translation. Okay, next slide, please. In terms of traffic recommendation, as I said, UDP is better for the section 6, forwarding performance, and TCP for the stateful transition technologies. Next slide, please. So for C scalability at end-to-end, yeah, this was added to section 8.5. The details again. Next slide, please, Al. And yeah, in terms of MTU, I want to explain this more. So basically, we have usually a virtual interface that achieves the translation or encapsulation, and that sometimes, especially for encapsulated for encapsulation, that can create an MTU mismatch because of a bigger MTU on the interface, on the virtual interface. So I think just setting the bigger MTU between the two should be enough. That's I think this recommendation should suffice. In terms of routing, I think for the simple test setup, so the one DUT and one tester, static routing might be enough. But for scalability, I think the dynamic routing should be used because it's just reasonable. And in that case, the recommendations in RFC 25444 for filtering the management and routing frames, I think can work here for transition technologies as well. So this completes the comments I covered. There are some comments I haven't covered yet in the next slide, please. Okay, have a comment.
Go back. Step right here again. On the question of routing, static routing versus dynamic routing, I always use dynamic routing because it was easy. The test gear produce the routing packets so that the device under test got the same set of routing things. I didn't have to configure it. It just made things much easier to use dynamic routing. So I wouldn't put the qualifier saying for more complicated setups. I did it for the most simple setup.
So for all setups, that's
I found that to be easiest because easiest for me as a tester because it minimized the configuration it had to do with the devices.
Well, yeah, if the tester already has the capability of filtering, it doesn't make sense to I agree.
This is mostly what you need to install routes in some of the devices. And what's the best way to do that? Well, you can sit there for a week with the command line, or you can just have the device send out routing packets.
Yeah, that makes sense.
Inherent in that recommendation is a kind of a waiting time for the learning to take place and for things to stabilize. But that's a sentence or two that you're cautioning the tester on. It still takes advantage of the simplicity of the automatic.
Yeah. I agree. I will change the text consequently. Yeah, I think it's better. Yeah. Okay, so what I haven't covered yet is Nalini's comment about DNS resolution. Thank you very much for that. And I'm actually still thinking and considering adding some DNS resolution performance metric. Maybe it will be called that, I don't know. But one example of what the target would be is the number of processed DNS requests per second. And this can be really useful in the case of translation-based translation technologies which actually need DNS, like NAT64 cannot really work without DNS64. So it will make sense to have this. So I think it's mandatory that I include this kind of metric into the draft. And the second was about jitter, or for disambiguation delay variation. And I read the recommended draft. Thank you very much. I'm still considering which one would be better between PDV and IPDV. Your input is very welcome in this case. So if you have any suggestions, that would help. Okay, so next slide, please. For next steps, I'm planning to propose solutions for DNS resolution and delay variation metrics, and of course continue revisions according to feedback. And I have two questions for BMWG. First of all, were the comments covered well enough? The people that actually made comments, their feedback would be greatly appreciated.
From my point of view, I thought so, and but I didn't make that many. Some of the things I commented on, you still have yet to address. So,
okay.
But I speaking as a participant, I think you're headed in the right direction.
Thank you very much. Can you tell me which one? Maybe I forgot about it. The comment, the one I didn't address. The delay variation. Okay. Yeah. That's okay. Do you have, by any chance, any suggestions between PDV, or it's not really. I think PDV is more like packet delay variation as opposed to inter-packet delay variation. Packet delay variation looks like a better choice, but I don't. It's hard to decide between the two, or I don't see advantages.
Al Morton, participant. So, as I said just a few minutes ago, it comes down to what you want to learn from the measurement you're making. And in these two widely used forms, the inter-packet delay variation, where you're basically comparing adjacent packets, to the packet delay variation, which uses the minimum delay as a reference. It's a kind of a shifted delay distribution that you characterize with various statistics, high percentiles or typical, and so forth. You can characterize both these things, but the one main difference is that inter-packet delay variation depends on the sequence of delays, and reference minimum delay distribution, what we call packet delay variation, is completely that. There are lots of circumstances where in live network testing it may be simpler to compare the delays of adjacent packets because you have limited state that you can store in embedded devices and so forth. Maybe you're worried about link disruptions and path changes and all sorts of things that happen in the laboratory. You also may have clock accuracy limitations that are not normally our problem in the laboratory. So it feels to me as though many of the circumstances that might bias your choice toward inter-packet delay variation don't really apply so much in benchmarking. But at the end of the day, it comes down to what you want to know. And I think, based on this RFC that I've been citing, 5481, most of the questions that people want to ask about like how much delay is would be necessary to have a jitter buffer accommodate this delay, how much there were several other tasks that we've looked at, and for those tasks the minimum delay shifted distribution seemed to answer those questions much more straightforwardly than inter-packet delay variation would. So I think that's that's the fundamental thing that we should probably decide as a group. What do we want to know from our delay variation measurements?
How do we get out of the way here?
Trying to decide what size jitter buffer to use. You need the end-to-end. You need the overall delay. The inter-packet delay latency variation, or inter-packet latency per se, drops out the absolute latency through the device. So you're missing the main thing that you need to know when you're talking about jitter buffer size. There are cases where I can imagine wanting to know the inter-packet jitter. It tells you a little bit about how the backplane might work. And it's a component in the end-to-end delay. But it's not enough information to know what the end-to-end delay is or what the variation is going to be. But it is helpful. It's not something you should just ignore. But in the real world, I think that it's almost useless.
I see. Well, since BMWG is not really the real world as we decided.
That was the way it was designed.
Yeah. So it seems to me that for stability, both of them are quite useful. Like they're quite useful measurements. I was actually wondering why not both. Like I don't see any problem with actually having both, not deciding between the two. It might be hard.
Both doesn't hurt. I think you get 95% of what you need out of the overall packet, overall packet jitter rather than the intermediate. There's some very minor things you might get with the intermediate, but it doesn't hurt to have it. I just don't know that it's worth the effort.
Yeah, it might not be worth the effort for like benchmarking tools to actually go through that overhead.
Yeah, Al Morton again. So that's about where I am too. I don't want to exclude one, the interpacket delay variation, but I think that we should have a kind of a high priority or preferred measurement that we believe will answer your questions, and then if you've got something more, then we can nail down the background scenario that Scott mentioned in real terms, then I think that would be worthwhile mentioning as well.
Maybe a should and a may. I was. Yeah.
Jacob Rappin, just a follow-on comment on that too. Yeah, I completely agree that we should have a recommended value, and that's the fact that because to your Scott's point, it's 95 or 99% of the cases you care about
More useful.
everything. Yeah, it's not just packet to packet. There is some cases like because you trade and you care like.
I guess for high.
Or looking at the back prints,
Use.
definitely make sure that we have recommended to use.
I see. Thank you very much. I was thinking high availability might be a use case in that, like for IPP, PDV, high availability measurements. So basically, like if you're testing for a game, like peer-to-peer network for games, in which stability is really important and the packets are really small and the frame rate pretty high. I think in that case, IPTV might be quite useful. So.
Scott Bradner again. I don't think that that's the case. I don't think it gains you anything. You get the only thing you don't get is a situation where a recognition of a situation where packets are too close together for the succeeding device.
Okay.
So there are cases where the buffering in a device can't keep up with relatively adjacent, and they need a little space in between. But that's a very narrow case. Everything else is the to the user. I don't care what the interpacket the care takes to get the overall packet out there.
First, for and most important, I agree with that. Okay, thank you very much for the comments. It's quite early to ask again, but do you think the draft could be adopted at some point by BMWG? That's why I changed the name.
I think that's a possibility. It's not a specific item mentioned on our charter at the moment.
Okay.
But we'll have some offline discussions and talk about how we can handle this, given that we've got this very detailed and very good proposal here right in front of us.
Okay.
So I think it may be a little premature to ask that question.
Yeah, it is.
But we will we'll consider that in some offline discussions and see what happens with the comments. The truth is that these are very important, and we've always been able to garner sufficient support up and down our management chain, so to speak, to take that.
I see. Thank you very much.
Scott Bradner, for my opinion, is that it's stuff that we should adopt.
Good.
Thank you.
Okay.
Just because you're chair doesn't mean that if you are out of the box, you don't at least have to buy a meter.
I'm trying to get this thing out without putting my eye out. Okay. So, benchmarking methodology working group did a small pivot in its work proposals when we rechartered to pick up this work on virtual network functions, basically the infrastructure for network function virtualization, and it was based on the strength of a couple of contributions and proposals that came in last March. And that was good timing because we were just about to recharter the working group. And so we did. And all of the chartered items that are on our charter now produced no controversy whatsoever, except for the virtual network function one. And really there, the questions were very friendly when we rechartered. It was about, is the benchmarking methodology working group going to decide architecture for the virtual network function world? And the answer resoundingly was no, obviously, but we had to make that clear in the wording. So this is a hot topic, and we're one of the first, among the first working groups in IETF to sort of pivot to take a look at it, and it makes perfect sense. It's a work that I was very excited about, and others, based on their comments and feedback and contributions here, are excited about it as well. So this draft is one of our deliverables on this work item. It's our first deliverable on this work item. It's considerations, the going in advice to benchmarking virtual network functions and their supporting infrastructure. So please skip ahead there, Sarah. Thank you. Okay. So a quick background. In version 1, we looked at these specific considerations and detailed them in the draft. Based on comments, there was a desire right away to be able to compare the virtual network functions with the physical network functions. And that means basically a reuse of the existing benchmarks where possible. We'd refine them. That's what we intended to do. And we have continuous emphasis on the black box benchmarks, which is our chartered work.
Scott Bradner, good cue. I was waiting to ask a question of why are you so focused on COTS? Box, why do you care?
The mantra of the network function virtualization world.
Why is that important to this?
And in truth, I think that in truth it's more specialized computing than common off the shelf.
Why does the benchmark working group?
Why do we care? Why do we care?
Testing a black box. You just said it.
Right. We care because if we have to configure if we have to configure the I think there's a good answer. If we have to configure these common off-the-shelf systems with multiple components. For example, if we're choosing the storage, if we're actually building these systems, and different systems with different construction of components will perform differently, then that's I believe that's an important test parameter to report, because now it's now basically one of the variables. Joel?
Yeah, so I think I can probably channel Scott here maybe in a slightly different way, which is that like the actual nature of the device under test is kind of an externality to the testing method, right? It's kind of irrelevant. I mean, it actually cause you to produce some determinations in your reporting, like say, unit performance per watt or that, but that's actually not that's not actually relevant to the testing process itself. So I think I think it is with respect to the actual considerations, it's an externality. I mean, it might be something that you remark on, but it's not actually a critical component of your.
This question. In the test, different if it's a COTS versus a box. What in the test is different if the box is painted purple versus green.
What's different what's different is only in that you would say what class of server with processor you use. Well, I think there's more variables to report on now, and so I think that was my point in section 3 of this draft, that it's not just about the iOS you're using or some internal software that you're using. You might report on that, the number of interfaces. I think there's more things that we need to be aware of now and report on. Sarah?
Sarah Banks, participant. One of the few examples I've seen probably just recently where it might make sense to call out costs I think using philosophies, but one thing that maybe we could take note of is in our space where in monitoring there's a huge chunk of folks who are saying, you know what, you can go ahead and monitor both production switching as well as monitoring, which traditionally in black box with black physical boxes, the way we've been buying them traditionally from vendors, you would have your network piece of gear over here doing network things, you would have your monitoring piece of device over here doing this, and now we're seeing a blend of the two. And does that affect your tests when you bring them into a dead wall?
Absolutely.
I would argue that's dirty all over the place, but it's happening, and so customers are going to ask, well, what does this mean, and how do you perform? So maybe you could consider making comments on, do we restrict it and say if you're going to do this but treat it as a black box, it could only be deployed as the network piece of infrastructure or the monitoring? Or would you consider allowing them to be somehow, I don't quite know how you would do that, but allowing the two to coexist and how you get clean data out of that, I don't know. But
that's the hard problem. And I think that's one we have to attack. I'm not sure that it's not easily solvable, and yet there may be ways to report the results that will calibrate things such that they would be useful in a kind of a shared environment. I have hopes for that. I'm not sure we can get there. Scott?
So Scott Bradner again. I would urge you just to remove the concept of COTS from this. What's go with group has always talked about is you don't factor anything about how it's built internally. You don't know anything about it. All you know is that it's got holes in the side that you put bits in, and you've got holes in the side the bits fall out of. And you get much more detail than that. I think you're doing yourself a disservice.
Really? All right. Well,
you can talk about the reporting aspect, sure, but not as part of. You don't say the COTS does that. You do this with the COTS. You do that with the COTS. You do it with the device under test.
Right. Well, I had intended to use device under test in any of the tests that we described, but I really was focused on reporting about the device under test in terms of its new bells and whistles that come down in configuration. That's really mostly where it was. It was in the reporting end. But no.
Alternate thought here, Al. So essentially, the fundamental difference in the way things are in NFV is, the separation of hardware and software. I mean, we have firewalls today, you can benchmark them, but hardware and software is bundled into a package, tested, right? You are essentially making some custom changes in hardware to optimize overall performance. But now coming to the world of NFV, we do not want to do that. We want to just open up the hardware. Basically, you can run any software and any hardware. Well, in this case, we want to call it, but the key concept is a separation. That means you are introducing more points. You can vendor software on that. So that is maybe that's one way to put it.
That it's more a general purpose, not specialized.
Okay, exactly.
Yeah.
Purpose, and so that means you have opened up.
It doesn't change the test. I think I'm still hung up on this, Scott. It changes what you report about the test, because now that's. But you're reporting on what you're reporting on all the things that we've reported on before, and in addition, there are that now we may want to examine in the general purpose computing space. Well, for example, have you got any idea how many different Intel processors there are in the Xenon family? I am Xeon family. I'm absolutely shocked and scared when I look at these selection tables now.
So I think what you're getting at is actually sort of a question of repeatability, and whether or not you can make assertions about generic classes of devices behaving in similar ways, which I think is actually a pretty bad assumption all the way around. And so it's not so much the commodity nature of it that you're describing, but the fact that you actually have to describe the device under test for the purposes of repeatability more descriptively than you did previously, which is something that I think does appear in the reporting with respect to what is this black box that we're testing, but it's not the nature of it as a commoditized thing. It's if you were to replicate this test, you actually need to live in an environment that looks like this, right? Which is maybe more. It's going to require and I have to go buy this particular router and run the software release on it to reproduce it under these conditions, right? But that's kind of a, oh, by the way, like this is actually the device under test, which is this thing with all of these software components, and they existed in this particular state at this time, right? And I think it may be the case that that's unrepeatable. There's no combination of those things that ever exists in the future. That's an interesting problem.
That's exactly right. And
So
go ahead, Scott.
So Scott Bradley, you may just want to get clear that when you're describing the device, you fully describe the device. Whatever wells and whistles.
Right.
But, I just think that it's a distraction from anywhere else but in talking about how you're reporting the test.
Okay. I got it. Barry?
I haven't read the document in its entirety. I just glanced at it. And that's the point of, one thing that's very different when you're testing a router, you know how many interfaces you have, and this group has, focused on how we do things concurrently, driving the device to break. Well, with virtualized, I think one of the challenges is you could take a platform and run a router on it, a firewall on it, 10 routers on it. I think it would go a long way just to help the community understand how to not only report on that, but just the test configuration. With when bare metal Red Hat, are you doing it on But I don't want to go into that because I know there'll always be the point that you can just report on that. But I think just helping the community understand how to define the level, and it's a whole new mix here.
Yeah, I think that word is worthwhile including here for sure, Barry. I'm sure all the note takers will put down that word so that I can mention it in the right place. Good, thanks. Move on.
Additional scope to cover additional metrics when that is in the real physical world, but in the virtual world, the software mentioned. I think there are some additional who do benchmarking metrics such as time to migrate a VM or the VNF. Those are all the as per that, I guess. These are all some of the metrics can be part of this. Even I have seen vendors who manage multiple VMs and they automatically scale up. Those are all some of the factors that can be additionally benchmarked of this.
very good. I tried to go to ones that I can bullet 3 there, and I appreciate your support. So.
Just to be clear, I think this is tremendously important in my day job today. So don't be discouraged by being pummeled. But it's got to be done in a way that winds up being useful. Right.
Yes, sir. May I have another?
Ashish Mishra here. Ashish Mishra. Because of comparing benchmarks that this would provide. One is against competing VNFs. You can have different VNFs run on the same system, same environment, and benchmark them, have a nice chart, decide which one's better. Realistically, what's going to happen is each vendor is going to do their own VNF testing and present the result. Is there any consideration given to defining that environment and standardizing the environment in which those VNFs can be tested, so that when they are reported to a customer, you have a consistent view of how your software is performing?
I think challenge. We may get some help from that, or in that area, from some of the open source projects that are kind of in the works now. There are sandboxes being developed in many different, at least 3 different sandboxes being built in the OP-NFV project. They're all sort of using the same pod structure with Intel processors and so forth. And I think that one of the things we're going to look at is, those kind of the variation across those. But I think I would be reluctant to nail down in a static document what server architecture we think is the standard, because things change so fast that. But I appreciate your point. And another part of my answer, though, is that I think each deploying organization will have their own take on their hardware for this year, and so they'll want to run those comparative tests on their systems.
I do agree. I'd much rather have IETF define that than have 5 different vendors define different standard setups. Yeah. It's just a painful prospect from an implementer's point of view.
Certainly understandable. Let's talk about that some more. I think it's a hard thing for us to do, but maybe a kind of an informal recommendation that kind of exists on the mailing list someplace would be helpful. I'm not sure. I know this is basically the one of the problems that we're most concerned about. It's the variability across these platforms and how to make meaningful. So maybe a characterization of various general purpose platform capabilities over a range of variables would be the thing that we're looking for when comparing to VNFs from different sources.
Right. To the discussion.
Again, not to pummel. I actually don't. My own use of this work in this space is not to compare environments, not to compare devices or pseudo devices. Mm-hmm. Is to find out how the one I'm using works. We have decided we're going to go down a bit, and we want to know how to design our software in that environment. This kind of benchmarking can tell us what are so good things to do in that environment. Is deploying virtual clouds a good idea? Is the performance so crappy that you might want to think about putting databases in each VPC? We can learn a lot about the environment we have chosen to use, where we're not choosing between environments.
Good point. Certainly one worth adding.
thoughts on the can add what all potentially in the configuration parameters? I was thinking power consumption basically a parameter. Today you can actually put the power in the configuration, of course. And the other one is
Well, let me stop you there, Remke. How would you provide as an ongoing power measurement during the test, or some sort of server specification that is or
focus policy. Basically, you say you limit the maximum amount of power, but that would be at a physical system. But and the second point is very valid. The dynamic power consumption, what is happening in the system, continuously exceeding any threshold.
Okay.
Exit threshold. Standards like IETF can do. So that is something which is useful. While we're developing this, because so far what has happened is each vendor, all that is taken care of and packaged, and now we're opening up all these.
Yes, this is the joy and the pain.
But there's more opportunity.
That's right.
And the other one I was thinking was around the metrics for actually conducting tests. For example, again in an opened up environment, measure things like CPU utilization, and various other things.
So those are actually internal metrics from the open source world here, or basically from the computing platforms. That I'm recommending that if there's something that people measure, which is coming from their platform of choice, that will help them determine utilizations later or performance later in an operational environment where they don't have the in-band measurements, so to speak. That it may be very helpful to collect those things and to provide them, but we're still emphasizing, obviously, the black box measurements in terms of the benchmarks. So it's supplemental information.
My only thought is that would have the impact on the test visibility, I think, perhaps.
Of course, yeah. It's
connecting the test is so useful.
Right. So I'll try to expand just to include that you mentioned there, but because I think they're good, and those are the ones I had in mind here. Good. Thanks.
Just want to my thoughts on the individual virtual network functions. I think that's great. So probably this is kind of a benchmark in infrastructure, virtual network functions. But to each virtual network function, there's an application.
Of course.
Probably, setting separate draft or drafts. For example, today there's a firewall implementation. Hey, what does it take to do a benchmarking for virtual firewall?
Absolutely. That's what I envisioned here. That really this is something that we've written down quickly as the advice and the information for folks who are going to subsequently propose the individual function benchmarking work. And what I'd like to propose is that we adopt this at a fairly sort of early stage, and then immediately start the BIS version, the updated version, as we go along and learn, rather than hold this up.
I totally agree. Yes.
We would update it as we learn it. So not only does it get published, but it's also a living document that we continue to add and revise considerations in. Yeah. So I'm on the same page with you. These things really have to be done one by one. This is just the overall guidance.
Excellent. Thank you, Al. And the last one was just the point I wanted to raise in the essentially infrastructure will have physical switches. In this case, what we're doing is separation of basically you'll be running probably OS from PC on some common hardware platform, right? So just maybe something worth considering is, are there any implications for benchmarking in that viewpoint?
In this hybrid environment of physical and virtual. Actually, that's good news. the more physical things we have in our system under test, those are the easy ones to characterize, so to speak. And then when we put a few virtual components in the path, now we've got this, the dependence and interactions that we would have hoped that we have to somehow corral. Given that we're in Texas, I think corral is a good word.
Yeah. So thank you, Al, for this is great work, and I'd be happy to.
Thank you, Romke.
Jacob, perhaps I think this is what definitely needed. There's a couple of comments on like the CPU and VMs and so on. I think in the draft you mentioned 50% load, and also at the noisy talker scenario where there's a VM with
Noisy neighbor.
Also how it scales, right? So if you have a firewall, how does that scale, how does that scale as you add more VMs to the firewall instance or routing instance or whatever it is? But I don't know if that should come in the specific firewall routing piece, or can we describe it here?
Well, it has to come there, but I think maybe we need a few sentences to ensure that people understand that scale testing is still one of our most important reported results. So thanks for that. So I think I'll move off of slide 2 now. Checking the time. Oh boy. So I'm gonna rush through the last few things here. So in version 2 we basically introduced this 3x3 matrix, and we looked at some different alternatives to reflecting the scale and capacity benchmarks somewhere in this matrix, including adding a new column and include in the existing columns, or to keep the capacity and scale specifications kind of separate from the matrix, and the results could be organized using this matrix too. So in some consultation, but not really finalizing this. Would you press the down arrow? Thanks. No trouble. So let's see here. So down at the bottom there, I think what I'd like to propose is that we keep capacity as a specification separate from the matrix, and that way, because it doesn't really fit within the matrix columns. Maybe I should bring up I think what I'll do is bring up the matrix so people can tell what the heck I'm talking about. Oh, there it is. It's right next. Yeah, good. I'm sorry, Sarah. I thought it was in the backup, and I was going to have to find it. So this is the current matrix. It's got communication functions along the left-hand column there, and then communications criteria are the columns. So, for example, a speed of virtual machine instantiation would go in that first cell there. Now you're activating or creating a VM. How fast can you do that? You would time that. So that's where that would go. And if you don't get a VM with the storage of correct size, or the size that you requested, that would be characterized under a metric that lands in the accuracy column. And if, for example, if you request a VM and it doesn't stand up, or it's dead on arrival, then there would be a reliability that we would look at. So if we were doing those operations, that's how they would roughly be categorized in this matrix. And this matrix is really just a way to see if we have covered the various possible performance metrics which might be specified on a system. And as we've applied this matrix in the ETSI NFV standards body, what we learned is that almost any time we left what could be an important, let's say an important row here, like deactivation of VMs and VNFs. Anytime we left that unvisited and unspecified, we found that came back and bit us in the butt. and so we ended up having to specify something like that later. So we've used the matrix effectively there, and I'm proposing that we begin to at least take a look at this here. Bhuvan has begun to look at that, and actually in some of the new ETSI testing work, they're looking at it as well. But Scott, please.
Scott Bradner again. Sounds like conformance testing. Did you get the VM you asked for? That's conformance.
And that's something we should avoid.
Well, we certainly historically have not run down that road too fast.
But I think that there's always been.
So I said that precisely. The way you described it, it sounds. There may be other ways to describe it which don't make it sound like conformance testing.
Yes. Yes. So the wording is going to be important, and we don't do conformance testing here exactly. So I will try to be more careful with that. Yes. So in fact, usually the accuracy is somehow shared between the speed or the correctness of outcome is shared between speed and accuracy. If you only count the correctly instantiated functions under speed, and then simply count the others under however that's defined under the accuracy and provider ratio, then really you're running one test and reporting both sides of it. And very oftentimes, if you're standing up thousands and thousands of VMs, you would get a few in each of these categories. So it's just a way to report both.
Sort of, Scott Bradner again, sort of like not reporting packets with checksum errors.
I'm sorry. It was something wrong.
Sort of like not reporting packets with checksum errors.
Sort of, like not reporting them.
That would be not reporting a VM that didn't conform.
And that's something we've done in the past to report packets with checksum errors.
Well, mostly we don't because the device throws them away.
Well, if we can't see them, we don't report them. but there may be something along the way that could. I think that's the completeness of this, that it allows for the specification of metrics that would catch everything. If in practice we can't see them, we have to assume that that's what happened, or something else even worse happened. Very good. So if you could go back to this one, yes. So I want to talk about this a little more with Bhuvan this week, and maybe with a few others. But I'm moving toward this proposed resolution of keeping capacity separate in the matrix. And I'll just say a few words about these others. The considerations for interactions, when we have the dependencies in the resources, shared things, the placement of VMs, the high availability, whether it's run as a virtual machine or bare metal, all of these are difficult, making our job more difficult. We have to somehow corral them as well. So, and as we discussed today, section 4.3, we consider new metrics for characterization. And we talked about PDV. We didn't talk about reordering much, but that's come up in our OP-NFV work, reporting mean delay and so forth. So in general, 2544, for example, had a report of latency. What we want to do now is go beyond that and report more about the quality of the packets that are being delivered at throughput level. Next slide. One more. So I wanted to mention related work, which keeps coming up in ETSI NFV. These links are active, so when you're able to download the slides, it'll take your right to some place where this is happening. We've got V-switch benchmarking requirements for various forms of acceleration. We want to be able to demonstrate that acceleration is improving things there. And pre-deployment testing of VNFs, and there's also some interoperability testing going on there, specification of that. In the open platform for NFV, we've extensively adopted the bench RFCs. We have begun to look at some interesting additions to those RFCs, such as what if you run for a really long time, and because of the probabilistic nature of the way software operates, that you have some background packet loss. It turns out some people are interested in that because they're going to be running these systems for a very long time. So we have at least one test that picks that up. It's kind of a soak test. We've got many new metrics that we're introducing here. It's consistent with some of the other things I've talked about. So when they say telco, they actually have IPPM in mind. So it's kind of a mix of worlds here, but it's the more detailed IPPM metrics. And there's quite a few other testing projects, some of which are functional testing and platform building and all sorts of things. In Open Daylight, they've actually taken Bhuvan's draft. A guy named Daniel Farrell looked at that, and I believe that he's working on something called Wrapped CBench. CBench is an open source SDN controller benchmarking program. It's no longer being maintained. According to Daniel, it would have been difficult to modify, and so he's wrapping it in other useful things, and that's called the Wrapped CBench, and you can take a look at that. And I was when I got tuned into this late last year, I was very pleased to go there and see that he was already referencing one of Bhuvan's drafts. So that's the best thing about this. Because we pivoted early, we're having an influence throughout the industry already, and people are already citing this considerations drafts in their work. So we've got the ball. We really move ahead here and have at the dawn of this industry that that Scott had in the 90s. So let's do that. Let's do that together. Next slide. So we've heard tons of further refinements on the draft today. I really appreciate that feedback. Thank you. And I think a future question will be how soon we want to adopt this as a working item. And Sarah's going to have to call consensus on that because I can't.
Can I get a feel for that? Ask for the adoption of the working group item there, but based on what I'm seeing in the room, based on a good amount of feedback that we've had online and here in the room today, I think we're in.
Excellent. Thank you very much.
Item for me.
Yes. Okay. Well, thanks very much, folks. I want to give the rest of the time, which is about 20 minutes, to Bhuvan. So please, let's get your slides going.
Thank you. Hi, good morning. I'm Bhuvan, one of the author of this. Close to it. This is fine. Okay. Right. So I'm Bhuvan, one of the author of the benchmarking SDN controller performance draft, and one other author, Sarah, is also in the room, and I believe other authors be participating remotely. So moving on to next. So today I'd like to give an update from the latest draft revision, which we have posted a day before the session. Sorry for posting it late, but nevertheless, I'll give an overview of changes that we have made in the latest revision. So maybe just for the benefit of newcomers, so the objective of the draft is to provide a comprehensive set of tests for benchmarking controllers, primarily from the performance, scalability, and reliability and security per se. And also we are trying to provide a standardized mechanism with which various controller designs can be benchmarked and reported. Yeah, moving on to next slide, please. I covered it. Yeah. From the history, so we have submitted the first version in March 2014, which was open flow specific, and there were a lot of comments on it, so that to make it more generic, so that the industry can use it. So based on that, we have submitted the next revision in October 2014. So that is more protocol agnostic, and I think there were wide acceptance for this draft, and there were also a lot of commands, review commands and things like that. So one of the thing we received during last meeting was to split the draft into two, one for defining the terminologies, and other for defining the test methodologies. So based on that, so we have submitted the latest revision, so two drafts, so one for terminology and the other methodology. So I'll move on to the updates, high-level changes that we have made to the latest revision. So the first one is I've already covered. So we have created two drafts, and the next one is we have also added additional metric and also reworded a couple of metrics for better clarity. And the next one is we have provided an example for benchmarking using this methodology for open flow controller. So I believe this will give more clarity on using these generic methodology and adapt to some specific needs. So this is also one of the comments from Mari's last meeting. So we have incorporated that. And also the last one is the comments extensively received from the list. So we have addressed it. We have incorporated in the latest revision. And just I want to quickly browse through the individual changes that I have listed there. So the first one, I didn't really put on all the metrics, only I have highlighted the one that underwent a change. So the first three is more of rewording the metrics title for better alignment and clarity. And the last one is the control session capacity is a new metric being added. So primarily focusing on measuring the maximum number of control sessions that the controller can maintain from the SDN node perspective. So that is the new metric being added. So this is from the metrics wise. And moving on to the comments that has been addressed. So on the terminology section, so we have provided more clarity for some of the definitions, that is flow, path, and other definitions. And also we have dropped a couple of definitions which are no more being used in the latest revision. And we have also added a few new definitions based on the comments from the last meeting. I think primarily the SDN application traffic endpoint being one of the comment I received from Maurice. And moving on to the other sections, so the test topology. So we have we have explicitly shown the path between the SDN nodes, so that it will be more useful in the topology. We state the path. So that was one of the comments we have received, and we have addressed that.
Forgive me if I missed part of the presentation.
open, so why are we calling it SDN controllers?
No, we are not open flow. We completely moved out of open flow. This is a generic methodology to benchmark any controller design, irrespective of what southbound protocol it supports.
That was came out of the first changes thing we had last March, which where was very specifically open flow. And I think actually I was one of the first ones to say, oh, wait, can we do more than that?
Yeah.
And so it's moved away from being open flow specific to being generic SDN.
Yeah, I'm afraid that there's so much ambiguity of what is in so much different functionality that I would suggest sticking with there's an open flow controller or this controller or that controller, because it's going to be really difficult to benchmark, say, an open flow controller versus an SDN controller could be a controller. Be a controller for a routed or a controller for virtual firewalls, and those all could be considered an SDN controller. It's a bit ambiguous.
I agree. So definition of an SDN controller, and then let's have that conversation.
Okay.
It's certainly something that I think about too. I angst about how much to spin this, or how in my day job I might spin this, but then technically what does that mean?
Sure. Yeah.
I agree, but I think that's where adding the definition of an SDN controller was trying to limit. Okay, we're saying in the context of this is what we're trying to do.
I don't know if we want SDN is here.
Agreed, and it's not. It's simply saying for the purposes of this document, here's what we're looking to limit. To look at that definition, and then let's come back and have that conversation and see what you think.
All right.
When the RFC was published, I think it came from the research group. There is a standardized terminology now, and Bhuvan has adopted. So I think we've resolved the difficulty that you've highlighted, which is a real one in the industry, but it's less so, I think, for this draft.
Right. Yeah. Thanks.
Radner, I was looking at your test setup.
Okay.
I don't quite get it. Where are the bits flowing?
Sorry?
You have a figure 1, you have a SDN application, interface going controller, southbound interface going to 3 SDN nodes, and you say that's setup. And I don't see what bits are flowing where and how what you're measuring, and I just don't see this picture doesn't describe to me how it works.
You mean the paths to the nodes, or how actually?
What is generating what signals, and what is timing what signals? I just don't see it in this diagram.
So
It is. Yeah, please.
So one of the actions that Bhuvan and I weren't able to sync on before we came into the meeting. So personally, I agree. I'm hope since we haven't talked, I hope you agree.
Yeah.
But it's definitely something that I'd like to address and clean up in the next rev.
Yeah, certainly. I think this is a point for discussion. Yeah, certainly we'll take it up.
I was just going to try to bring up that.
I don't think anybody would.
Okay. Well,
Yeah, I think that's a point. I think we may need to relook at it. Yeah, I agree. Right. So on the test considerations, so we have recommended the test traffics being used while benchmarking the controller, and we also reworded a couple of sections for better clarity. Earlier we mentioned as measurement accuracy, but actually we are talking about the point of measurement, so we have reworded that title based on the command. And also we have added additional connectivity recommendation between the SDN node and the controller, so that the in-between shouldn't constrain that benchmarking. That recommendation been added, and also we have added additional attributes for reporting, so that it can include the hardware specification and the test setups that being used for the test. Yeah, Ramki.
So one aspect I was thinking is that Ramki Krishnan, Dell. So one aspect I was thinking about, the SDN controller benchmarking. SDN controllers, the performance, so many aspects depends on the deployment. Basically, there's enterprise type of deployment, there's service provider, or there's more telco types.
Mm-hmm.
So I do think while we want to keep this generic, but it may be worth bringing that perspective, because the tests you would do are quite different. What you do benchmarking. And again, position is not just an open flow control. It's much beyond that.
Yeah, to answer your question, I think, yeah, we have seen implementation of controller, even if you take Open Daylight, so they have three set of versions, right? So it varies on the application per se, but as such, the base functionality, if you see data center or be it enterprise or be it in the service provider, I believe it's the same. It's only the application that they pack to address the needs of the telco and the data center is slightly varying. So,
Yes,
so that way.
I agree. Yes and no in the sense. So the moment some of the applications are packaged within a controller, right? Then they become part of the controller, right? It's not truly an app, right? So it's like basic. I mean, yes, I agree that the very basic set is totally common, but are we scoping? Is this benchmarking about just doing the very basics, or is it like basic plus specific to those deployments? I think that's kind of the question we need to answer.
Yeah, I think this is one of the question that I have already answered through the mailing list also. I think it's fine. Yeah, just to clarify also others, but still we can even look at it if there is a lot of discrepancies in the answer. So this provides high-level methodologies to benchmark controllers. Maybe I'm pretty sure each environment will have different requirements, or even a controller supporting different protocols may have some additional tests to be verified. So I believe that can be an extension to this draft. So that could be the way, I guess, to proceed forward. Otherwise, it's very hard to, if you start look at every small dimension, maybe some of the metrics may not be really important for other environment. So it's very hard, but rather trying to define a generic platform, so over which maybe an additional test methodologies can be built out for specific environment needs, I guess so.
I totally with you. Yeah,
All
I think
right.
if you can clarify that in the draft, and also, I mean, two possible plans. One is we have sections in the draft for those additional, deployment-centric benchmarking tests, or it could be separate drafts.
Okay.
So to
Makes sense.
clarify that.
Perfect. Thanks. And coming to the benchmarking test, so we've redefined a couple of test procedures. So one is the message processing time. So earlier it was more like sending as many packet as possible for the given test duration and deriving the time for processing individual messages. So that is how it was defined. But there was a question asked that in case if the test generator has a limitation, then ideally it may attribute the controller. I mean, this may attribute the delay for the controller per se. So we have redefined such that so every message when you send, take the time, and when you receive the response, take the time. So calculate the difference. Some of the differences of the time will provide this metric, so that will be more accurate. So that is how we have redefined the message processing time, and also we have added additional recommendation for the another test called message processing rate. So wherein to ensure that the intermediate device connecting the SDN nodes and the controller shouldn't be an overhead or shouldn't limit the processing rate. So that recommendation been added as part of this test. And also for exception handling, I think we have given more clarity on generating incorrect frame. I believe this is one of the comment from Scott last meeting. So we have clarified what frames, what are categorized as incorrect frames, since the incorrect frame shouldn't be dropped in between before reaching the controller. So that we have clarified more on that per se. And also we've defined the scalability test network discovery size, so that earlier it was like a number of nodes being discovered within the stipulated time, but there was a query asked that the scalability shouldn't restrict with the time, so we have redefined such that it determines the maximum node that it can determine. It's a capability of controller to determine the number of nodes in the network, so that is how it's been redefined in the latest revision. Yeah, please.
Ashish Mishra from Sienna. In the exception handling, why are we providing guidance on how exceptions should be handled, or how incorrect frames should be handled? That's more of a protocol architecture or a system architecture.
Okay. To clarify that, so we are trying to benchmark the deviation from the from the baseline testing as compared to when a controller encounters an incorrect frame handling or a network events. So how far it deviates from the baseline performance that is provide as part of the exception handling. We are not really dealing with how the controller handles that. Rather, we provide the deviation in case if it is 1% of error, then what is the deviation from the baseline performance, and if it is 2%, so what is the deviation. So that is how this section been designed.
But there is an almost infinite number of combinations we can come up with when it comes to measuring the deviation in performance when processing a valid frame, which there could be many different types of valid frames going to different software components within the SDN controller, and handling exception frames, which could again be many different types. It could be a completely acceptable frame type with one invalid bit set somewhere, or it could be a frame type that is not accepted by the system at all. So
it's a lot of possibilities.
It's too many possibilities, and to the point that even if we do, what information are they going to provide you?
Yeah, it is kind of a robustness test. Try to categorize or characterize the controller behavior. Yeah, I understand your point. Yeah, there are the error not necessarily in one particular bit, or I understand your point, but this is more of a robustness test that try to categorize the controller performance when it encounters such a scenario. Since in a real time, yeah, I'm pretty sure this is a lab environment, but just to extrapolate this data to real time, so when there you may receive more network events and you may receive some errored packet. So such cases, right, so whatever baseline performance you obtained here, so may not be realistic there, right? So at least you also provide the other dimension that suppose in case if a controller encounters additional network events or an error, so then how far it deviates. Maybe some controller be more robust. This try to determine the robustness of a controller rather than how they handle those aspects.
Right. So if we did a network, you define these metrics for each protocol separately. You won't define it for a, for example, right? SDN controller is similar. It's a mix of many different individual components. Mm-hmm. Each individual component will have different metrics for the message processing time and exception handling. It won't be
discussion point, I think probably will put it across the mailing list. So, yeah, we have 3, 4, 8 take at least 5 10 minutes. And the next step, so can this be adapted as an work group item? So this is one. Right.
Folks have read